In this video, we're going to do a couple more examples of linear programming. So the first one is we want to determine the minimum value of z equals 2x plus y subject to all of these constraints. Okay, so the z equals 2x plus y is our objective function. Okay, so we don't really use that until the end. Okay, these 5 inequalities are our constraints. So we want to graph them. So I'm going to start by doing 1 and 2. So these inequalities down here. So x is bigger than 0. Y is bigger than or equal to 0, both of them. So I'm going to put them on my graph. So x equals 0 is the y-axis. Okay, y equals to 0 is the x-axis. And we want to be bigger than 0 in both cases. So we need to be to the right of the y-axis and above the x-axis. Okay, so all of that part is gone from our feasible set. The next one I'm going to do is x less than or equal to 7. So x equals 7 is a vertical line. Okay, similar to x equals 0. So it's a vertical line, 1, 2, 3, 4, 5, 6, 7. Okay, so it's a vertical line right here. So this is x equals 7, and we want to be less than or equal to this, to 7. So we should be to the left of this line, but if you're not sure, you can always test a point. Okay, so we could test 0, 0 if you want. So 0 for x is less than or equal to 7. Okay, that's true. So 0, 0 is on the right side, which means that everything on the other side is not in the feasible set. Okay, so all that part is gone. Oops. Let's do a green now. Okay, so let's do the next one. Okay, so 3x plus 4y equals 24. So I'm just going to find 2 points on this line. So let's say when x is 0, I'm going to have 4y equals to 24. So when I divide by 4, I get y equals 6. So we have a point at 0, 6. When y equals to 0, I get 3x equals 24, sorry. So when I divide by 3, I get x equals 8. Which means I have a point at 8, 0. Okay, so I'm going to be over here, and then at 6, 1, 2, 3, 4, 5, 6. Okay, so here's our line. So this is 3x plus 4y equals 24. And now we want to check a point. So let's test 0, 0. And we want it bigger than. Okay, so 3 times 0 plus 4 times 0 bigger than or equal to 24. Well, that says 0 is bigger than or equal to 24. So that is false. Okay, so that means that 0, 0 is on the wrong side. So all of this is gone. Okay, and now we have one more to do. Let's do it in orange maybe. Okay, so here it's 2x minus y equals to 0. So when I do x equals 0, I get negative y equals 0, which is y equals 0. So I have a point at 0, 0. Now because it goes through the origin, I don't want to pick y equals 0, so we could pick a different x. Okay, maybe x is, I don't know, 3. So that means 2 times 3 minus y is equal to 0. So that means that y has to be 6. So we get a point at 3, 6. Okay, so now we graph that. It goes through 0, 0, 3, 1, 2, 3, 4, 5. And it goes through 3, 6. Okay, so here is our line. 2x minus y equals 0. And now we need to test a point, but we cannot test 0, 0 as 0, 0 is on the line. So maybe I'll test 5, 0. I don't know, something on the x-axis or the y-axis is usually nice. So if I do 5, 0, it's going to be 2 times 5 minus 0, and I want that to be bigger than or equal to 0. Okay, so that means that 10 is bigger than or equal to 0. Okay, this is true. So the point I tested, 1, 2, 3, 4, is here. Okay, so it's right here. And it's on the right side. So that means that I want to shade the opposite side. Okay, so that means that everything above this line is now gone as well. So our feasible set is this little triangle bit here. Okay, and it has 3 corner points. Okay, so let's call it A, B, and C. So to find A, okay, so A is the intersection of x equals 7 and the green line, which is 3x plus 4y equals 24. Okay, so what we want to do, we can use substitution. We already have x solved for, so I'm just going to plug 7 in for x. Okay, so I get 21 plus 4y is equal to 24, which that means that 4y should be equal to 3 if I subtract 21 on both sides, which means that y is 3 over 4. Okay, so the coordinates for A are 7 and 0.75. Okay, for B, again, oops. Okay, so again, we have x equals 7, but this time we're on the orange line, so I have 2x minus y is equal to 0. So if I plug 7 in, 2 times 7 minus y equals 0. That tells me that y has to be 14. So the coordinates here are 7, 14. Okay, and then lastly we want to find C, and it is on the orange line and the green line. Okay, so I'm going to take this first one. This means that y is 2 times x, and I'm going to plug that into the second one. So I have 3x plus 4 times 2x is equal to 24. So that's 3x plus 8x is 24, which means 11x is 24, which means that x is 24 over 11. And the y value is going to be 2 times that. So it's 48 over 11. Now if we compute these, x is 2.182 and y is 4.364 approximately. Okay, so those are our coordinates for C. I didn't really leave myself enough room here. So we want to find the minimum value. So what we want to do is just plug them in. Okay, so we have our corner point. Okay, and then our z value, which is 2x plus y. So at corner point A, maybe I'll write this down. So corner point A was 7 and 0.3, no, I lied, 0.75. So that's going to be z is 14.75. Okay, B was 7 and 14. So z is going to be 14 plus 14, so 28. And C, I have 24 over 11 and 48 over 11. So z is going to be 48 over 11 plus 48 over 11, which is 96 over 11. Which is 8.727. Okay, and that happens to be the smallest z. So the minimum z is 96 over 11, okay, but in a decimal, 8.727, which occurs when x is 24 over 11 and y is 48 over 11. So that would be the minimum value. Okay, let's try a word problem. So, an office is designating a small room to hold records. The room has 60 square feet available for cabinets, and there are two types. There are two types of cabinets the company is considering. So there's a small one that takes up 3 square feet of space and holds 100 records, costs $8. There's a large one that takes up 5 square feet, holds 200 records, and costs $20. How many of each type should they buy in order to minimize the cost? Okay, so this is telling us that our objective is to minimize the cost. Okay, and we want to know how many of each type of cabinet. So these are probably our variables. So let's define our variables. So I'm going to let x be the number of small cabinets that they purchase. And y can be the number of large cabinets. Okay, so then the cost, so we want to minimize C, I'm going to call it C is for cost. So for each small cabinet we pay $8, so the cost for the small cabinets is 8x, and the cost for the large cabinets is 20y. Okay. And then subject to, so what are our constraints? Well, the space constraint. So we know that we have at most 60 square feet. Each small cabinet takes up 3 square feet, and each large one takes up 5 square feet. So we're going to have 3x plus 5y can be at most 60. The number of records they hold. So the small ones hold 100 records each. The big ones hold 200. So the number of records we are able to hold is 100x plus 200y, and we want that to be at least 2200. And then because these are counting the number of things, we need each of them to be positive. So that's our linear programming problem. So we want to try to solve it. So I'm going to start by doing the easy ones. So x equals 0 and y equals 0, and we want them to be bigger than 0, so we can get rid of the left and the bottom. Okay, and then let's do the 100x plus 200y equals 2200. So when x is 0, we have 200y equals 2200. So when I divide by 200, I get y equals 11. Okay, when I do y equals to 0, I get 100x equals 2200. So if I divide by 100, I get x is 22, which isn't on our grid, but that's okay, we can make it work. So 0 and 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, this... Okay, so here's 19, 20, 21, and 22. Okay, so that's where our other point goes. And then we connect this with a line. Okay, so this is our 100x plus 200y equals 2200 line. And then we want to test. Okay, so if I test 0, 0, I get 0 plus 0 bigger than or equal to 2200. So that's false. So 0, 0 is on the wrong side. So I'm going to get rid of the side that has 0, 0. So all of this is gone. Okay, now we have to do the other line. So maybe let's do it here. So 3x plus 5y equals 60. So x equals 0 means 5y equals 60, which is y is 12. Y equals 0 means that 3x is equal to 60, which means that x is equal to 20. So we have 0 and 12 and 20 and 0. So it's a similar line. Okay, so this one is the 3x plus 5y equals 60. Okay, we want to test a point. So if we test 0, 0 again, it's going to be, oops, there we go, 0 plus 0 less than or equal to 60. Okay, that's true. So 0, 0 is on the right side this time. So I want to get rid of everything above this blue line. Okay, so it might look like everything is shaded, but in fact, there's this tiny little triangle bit. Okay, that tiny bit is our feasible set. Okay, so again, we have 3 corner points. So I'm going to call them A, B, and C. And A and B we already know because we plotted them. So A was 0, 11, and B was 0, 12. And C is the intersection, C is the intersection of these two lines. Okay, so we need to find C. So let's just take one of these and solve. I'm going to take the 100, 201 and solve for x maybe. So 100x is equal to 2200 minus 200y. So x is equal to 22 minus 2y. Okay, and then I can plug that into the other one. So 3 times 22 minus 2y plus 5y equals 60. Okay, so that is 66 minus 6y plus 5y equals 60. So that's negative y equals negative 6. So y is equal to 6, which means then that x is 22 minus 2 times 6, so minus 12. So x is 10. Okay, so our point C is 10, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Okay, so we're a little bit off here, but it's kind of hard because these lines are so close together. So it's close enough, I would think I wouldn't be so worried. Now we want to actually find the minimum. So we're going to do our table. Corner point. Okay, and then our cost equation was 8x plus 20y. Okay, so if we compute the cost, so for the first one it's going to be 0 plus 20 times 11, so I'm going to get 220. For B, it's going to be 0 plus 20 times 12, so I get 240. And for C, it's going to be 8 times 10 plus 20 times 6, which is 80, plus 120, so that's $200. So now we read the question again. How many of each type should they buy in order to minimize the cost? So they should get 8 small, I lied, sorry, 10 small, 10 small and 6 large cabinets to minimize, can't spell today, minimize cost to $200 and be able to store at least 2,200 records. So you should get in the habit of actually making sure that you answer these questions, especially when it's a word problem.